where can we locate this applied force P so that all of the tensions are going to be equal in the three ropes, E, F, A, B, and C, D. So we're trying to find that coordinate, that pair X, Y. So we're given, or we're going to assume, or our constraint is that all the tensions are equal. So TEF equals TAB equals TCD. And I'm just going to call that T to have less writing to do. All right, so all tensions in those three ropes are equal, and that's what we're trying to find, the XY that makes it so. So the object we want to choose to isolate, here it's going to be fairly straightforward. It's just a triangular piece. We're cutting it away from the cables, so we'll have the tension in the cables. And again, we have that applied load P acting on it as well. I'm going to stick with the given coordinate system. So we have point C, we have point E, we have point A. So it's 2 meters from A to E and 2 meters from A to C. So we have this applied load P. That's going to be a variable X from the Y-axis and a variable we're looking for Y from the X-axis. And then at A, E, and C, we'll have the tension in the cables. In this case, they're all vertical, and they all have the same value of T. So looking at our free body diagram here, we actually have, this is going to be purely algebraic, but we have T, we have P, we have Y, and X. So this one's a little bit different than some other standard 3D equilibrium ones, but our solution is still going to be the same method to find, again, the X and the Y that will make this true. Questions on the free body diagram for this one? So based on the free body diagram, we can get two of our equations, sum of forces X and sum of forces Y. Both of those just give us 0 equals 0 because nothing happens in the X or the Y direction here. But then in the Z direction, here we have a negative P plus 3T. So from equation 3, we'll use this later. We can solve that force P must be equal to 3 times T. All right, so those are our 3 force equations. Only one of them helped us out here. If we look at the moment equation, we can take the moment about a point. So based on the free body diagram, what looks like the easiest point to take the moment about? Right, I would say A, it's the origin, so it makes the position vectors easy to find. It has a value of T there, so it reduces the number of cross products by 1. So A is probably your best bet for this one. Right, so we'll start with the tension at E here. So we need the position vector from A to E. We have to go 2 in the I to get there. And then the force is 0, 0, T. And it really doesn't matter what units these are in, I'll just say it's in newtons. We'll have a cross product then from this tension around A. So it's going to be the position vector AC, which is 0, 2, 0. And the force is also 0, 0, T in the K direction. And then the moment caused by the applied load P. So the force is going to be 0, 0, negative P. And to get from A to where it's being applied, we have to go X in the I direction and then Y in the j direction. So we have x, y, and 0. Okay, so x and y are variables here. Again, that's what ultimately we're trying to find, the x and the y that make the rest of this true, that those three tensions are equal. So if we carry out these cross products, the i's are going to be 2t minus p times y in the I hat direction. And then we're going to get p times x minus 2t in the j direction. And then 0 in the k direction. I rearranged it a little bit here. Saying this equal to 0, 2t is p times y. And saying this equal to 0, putting 2t on the other side, 2t is p times x. That's actually 4 and 5. From the last one, we just get 0 equals 0, which again is true, but doesn't add anything. All right, so last step, how do we find x and y?
4, 5, and 6 are from the I hat, the j hat, the k hat equation that we did previous.
Right, so that's just from here. So that's saying this equal to 0, this equal to 0, and then this equal to 0. So that's where 4, 5, and 6 come from. Right, I have the solution from equation 3. So now I can get everything, so 2t is equal to 3t times y, and 2t is 3t times x, presuming t is not 0. So that means that x has to be located, or the x value is 2/3 of a meter, and y is 2/3 of a meter.